this is second part of our part 1 under wave, and it will be based on terms used in describing wave and equation of progressive wave. And when somebody is talking about wave, there are some terms you'll be expecting that particular person to mention, such as frequency, wavelength, crest, torque. And to make our topic easier, we are going to use wave motion to explain the topic. Now, when we are talking about wave, we are expecting it to move in form of what? Sinusoidal. This point is called point of equilibrium. This is point of equilibrium. So we have point of maximum displacement. So it will move up like this at what? To reach point of maximum displacement, coming back to equilibrium, then minimum displacement, and so on and so forth like this. So this is what? Wave motion. The first thing is amplitude. The maximum displacement of a wave is called amplitude. Amplitude. Amplitude can be defined as maximum displacement of wave from equilibrium point or point of rest. This point is called equilibrium position or point of rest. From this place to the point of crest is called amplitude. So after the amplitude, we see have a what? A crest. What is crest? Crest is the point of maximum displacement. This place is called crest. Then this one is called trough. Is the opposite of crest. So crest, maximum displacement, trough, minimum displacement. That is maximum displacement along what? Positive axis of y. Then minimum displacement along what? Negative part of what? Y is called trough. Then the distance between this crest and the next one is called wavelength. 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 Please, if you want to define wavelength, don't define it as distance between two crests. It's wrong. Wavelength is distance between two successive crests. Because if you have another crest here, this place, so if you now say distance between two crests, mean you may refer to distance between this crest and the next one. Therefore, it must be two successive crests. This crest and this crest. That is what? Wavelength. So the distance between two successive crests is called wavelength. Then another term is frequency. Frequency. What is frequency? The number of oscillations complete in a second is called frequency F. So we replace it with F, and the unit is what? Hertz. H. Then the unit of this one is meter. M. Meter. Then amplitude also is mentioned in meter. So don't forget I said wavelength is distance between successive crests. Then amplitude is maximum displacement from equilibrium position. Then frequency is the number of complete oscillation in 1 second. Then the next one is period. Then what is period? That is time taken in complete one oscillation. How long will it take a wave to complete one oscillation is called period. And we represent it with what? T, which is mentioned in seconds. It is mentioned in seconds. Then after that one, we still have another other terms like speed. That is distance covered in 1 second. That is distance covered per unit time. Distance covered per unit time. Therefore, we can relate speed V. So we can relate the three together. Over the four. Relationship between wavelength, frequency, period, and speed. So in that case, don't forget in our normal motion, it says speed is equal to distance over time. So under wave, our distance will be replaced with what? Wavelength. Don't forget, wavelength is distance between two successive crests. So therefore, you can easily derive the relationship between the three. So therefore, speed V is equal to distance. Instead of distance, use what? wavelength lambda, which is mentioned in meter. Wavelength over time. Then what is wavelength? Wavelength is represented with what? Lambda. While this one is t. So therefore, and from our definition, since frequency is number of oscillation complete in 1 second, while period is time taken to complete oscillation, it means that frequency is a reciprocal of period, while period is also what? Reciprocal of frequency. So take note, we have velocity is equal to what? Lambda, that is speed is equal to lambda over time. So this place, we can write this one as V is equal to lambda multiplied by 1 over t. This one too means over 1. So we can replace 1 over t with f. So therefore, we can say V is equal to f lambda. So this is what? The relationship between speed, frequency, lambda, and period. Therefore, we can say speed is equal to f lambda. Take note of this formula. We still make use of it when we get to equation of progressive wave. So we still have other terms like phase. Two particles are said to be in phase when they are in the same displacement along the same direction. Like what we had before, we have this one like this. So if you have a particle here, let's say particle A, then another one here, particle B, then particle C, particle D here, particle E, particle F, particle K, particle N, then particle N. Now, so look at it. Here wave is going up, it's coming down here. So it means this particle and this particle, though they are in the same particular height, but they are not in phase. And a particle or a wave are said to be in phase if they are at the same vertical displacement in the same direction. So here the direction of wave is upward, this one is downward. So therefore, this one and this one, they are not in phase unless you have another one around this place. If you have R here, this one is going up, it's going up here too. So B and R, they are said to be in phase. So N and D and N, they are said to be in phase. So if you have another one here, let's say we have particle particle N here. So A and N, they are said to be in phase. This is summary of some terms used in describing wave. Mostly, don't forget how to relate speed, wavelength, frequency, and period together. We have period T is equal to 1 over F. Then F also is equal to 1 over T. Then V is equal to F lambda. So the next one will be equation of progressive wave, which we are going to make use of this one under it. Now, don't forget another way of classifying wave is to say standing wave and progressive wave. So when we have two waves moving in opposite direction and they have the same amplitude, by the time they combine together, they are going to form standing wave. That is, there will be no what? Wave again. And when we are talking about terms used in describing, in that case, if you have another wave moving like this, from here, like this, so we can still generate another terms here. So this point will serve as what? This is point of node, where there is no wave. So in that case, we have tandem wave. Then this is point of antinode, antinode. Therefore, antinode is point of maximum wave, while node is point of what? Zero wave. When two opposite wave of the same amplitude and frequency combine together. So in that case, we are going to deal with only progressive wave. That is the wave that moves from one point to another. So we are going to generate their equation, that is equation of progressive wave. And if you look at it, the wave motion is in form of sinusoidal. So it forms sine form. Therefore, wave and simple harmonic motion, they are in one way or the other related. Don't forget that we have under simple harmonic motion, T omega is equal to theta over time. Please take note. Therefore, this theta is equal to omega t. So when we start deriving the equation, we can replace our theta with omega t. And don't forget omega itself. Omega is equal to 2 pi f. So we'll be making use of this equation along our derivation. Now, let's start y with, this is what? One equation equal to a sine theta. Y is equal to a sine theta. So therefore, our theta can be replaced with omega t, like I just said now. So we are going to have y now is equal to a sine omega t. So this omega t, since omega is 2 pi f, so therefore we can still replace omega with 2 pi f. Therefore, y is equal to a sine 2 pi f t. You can see the system. So now, what is our f? In our previous discussion, we said v is equal to f lambda. Then let's make this f the subject of formula. Therefore, f is equal to v over lambda. So we can replace this f with v over lambda. So therefore, y is equal to a sine 2 pi. Instead of f, we use v over lambda. That's v over lambda, then multiply by t. Good. Then this is for wave. What of ordinary motion? In ordinary motion, we have v is equal to displacement x over t. So in that case, our displacement s is equal to vt. Please, let's take note of this one and this one. This one, so therefore we can also replace vt with x. So we are going to generate two different waves now. So just like when we have the first wave, we are talking about progressive wave. Therefore, when you have two waves moving in the same direction of the same amplitude, when they combine together, they are going to form larger wave. So let's say this is one. Then the second one, we have what? y2 is equal to a sine 2 pi. But instead, we just want to make some difference between the first and the second one. This first one, vt, will be here. Then the second one, we want to replace it. Instead of vt, we want to use x because our x is equal to vt. Just to make it different from the first one. Therefore, we have the second one, we now the y2 is equal to a sine 2 pi. Then instead of vt, we have x over lambda. Simple. So this would now lead us to take note to equation of progressive wave. This is the first one, this is the second one. So it depends. You can take away this one from this or take away this one from this. Just make sure you subtract one from the other. So let's subtract equation. Okay, let's call this one equation star star. Subtract equation star from equation star star. So in that case, we are going to have y1 minus y2. We still give you y. This. So we have. So we say y1 plus y1 minus y2 will still give you y. That y is equal to a sine 2 pi vt over lambda minus a sine 2 pi x over lambda. That's all. The factor common thing here, so it now gives us what is common. A sine is common, even 2 pi is common. So we now have, you can have a sine, open bracket, 2 pi phi t over lambda minus, a sine is already outside, so now have 2 pi x over lambda. So you continue like that, depend on given equation. Look at the question like this. The question says the equation, this equation represents what? The equation of progressive wave. So we now compare this and this together. You compare this one and this, and if you look at it, you see that this 5 is in place of this A. Therefore, the amplitude, question number 1, the amplitude is equal to 5 meter. Then compare this and this. Thank God, in some questions they will factor something out here. If 2 pi or whatever is factored here, you too, you factor that particular thing out here. But since nothing is factored out, just compare this and this directly, then this and this. So we have to find amplitude. We have done that. The next one is what? Wavelength. So in that case, I will compare this and this together. Therefore, we are going to have 2 pi x is equal to 0.4 pi x. So pi, x cancel x, pi cancel pi. And this one is over lambda, 2 pi x over lambda. This one is 2 pi x over lambda, So look at it, it means 2 over lambda is equal to 0.4. Then you cross multiply. So it means 0.4 pi, 0.5 lambda is equal to 2. Therefore, lambda is equal to 2 divided by 0.4, which is something at 20 over 4. And 20 over 4 will give you 5. So this one means lambda is also what? 5 meter. Now, the next one is, we have done for wavelength, you need frequency. Then you can still take this one and this. So if we take this and this, so you are going to have our wave, don't forget our wavelength is 5, our amplitude is what? 5 too. Now, then let's determine the frequency, compare this and this. Therefore, 2 pi ft is equal to 100 pi t. So this t cancel this pi cancel this pi. Therefore, 2f is equal to 100. Then you divide both sides by 2. Therefore, our f is equal to 100 over 2. So f is equal to 50. That's all. Then the next one is period. So from our formula, the relationship between period and frequency, I say they are what? Reciprocal of each other. So you can easily say t is equal to 1 over f. Then our f is 50. Therefore, t is equal to 1 over 50. And what is 1 over 50? So 1 over 50 will give you is 0.02. 0.02. So that is 0.02 seconds. That's our period. Then the next one is speed. Very simple. Go to the formula that says V is equal to F lambda. You know your F to be 50. Multiply by what is our lambda? Our lambda is 5. So it will now become what? That is 250 meter per second. So that's that about that.